Hello everyone, in this video I will show you how to design a PCB printed circuit board in Proteus. Double click on the icon, the window is open, click on file, next project, renaming the project as project 1, save it somewhere else, click on browse. I want to save it on E drive, new folder, next. I want to create the schematic on A4. Next, I want to create the PCB and it is a singular PCB. Now, firmware project is needed. Click on finish. Two windows are open. First tab, it is a schematic capture in which we are drawing the circuit, and second is for designing the PCB. Go to the first schematic capture, and on the bottom side, left side, there are some icons. First one is the selection mode, and second one is the component mode, and one important, that is the terminals mode. Go to component mode, click on component mode where we can select the components, and here I want to connect a relay. I want to interface a relay with the Atmega 328. So, click on the component. First I want to select the Atmega, click on P. P indicates the PIC devices. Type the keyword Atmega 328P. Click on here. The first block shows the preview, and second is the PCB preview, or it is known as footprint. Click OK, and it is listed here. Click on the Atmega 328P. A small diagram is shown here. When the blue color is on here, it is selected, and place the mouse over the schematic. Click it here. You can place that Atmega here. So, this is the page, schematic page. We can create that diagram or the circuit. So, under the bottom, the file name and design titles are given. So, we can change the title also. You just change it first before the designing. So, click on the design tab, edit design properties, title. I am giving it as example. FTP 41. Document number given it as 101, revision 1.0, author. Okay. Click on anywhere else, that is, it will be renamed the project one example, and the location is also given, that is, and the author. First I want to connect that reset, connecting to VCC through a resistor of 10K. Click on P, PIC devices, type resistor. From the category, click on the resistor. Subcategory, there are different types of resistors, different wattages. I am selecting 0.6 watt. I need 10K. Click on this 10K. OK. So, this is a place, and click it here. So, I want to rotate that. I want to place the mouse over that, right click. There are two options, rotate clockwise and rotate anti-clockwise. Rotating. Otherwise, you can rotate here also. Here also, that is, click on here, then the two buttons, that is clockwise and anti-clockwise. Click it here, you can change or you can rotate. Okay. Then connecting the pin number 1 to here and connecting a VCC. So go to terminal mode, click on power, click it here. Double click on the power and give the name, click on the drop down arrow, click select VCC. Okay. Then I want to connect a crystal to the pins 9 and 10. Go to the component mode, click on P, peak devices, type crystal. I want to rotate, place it here. Okay. And the value is 11.0592 megahertz. Click on that crystal, double click, 11.0592 megahertz. Want to connect two capacitors of 33 picofarad. Click on P, capacitor. Under subcategory there are different types of capacitor. I am selecting ceramic disc. I need 33 PF. Okay. Placing it here. Connecting the ground, go to terminal mode, click on ground, place it here. Okay. Then connecting a capacitor, it is nothing for the filtering. Go to component mode, click on P, capacitor, or we have already selected that is one capacitor here, rotated. I can change the value to 104, double click here, give 104. Okay. Need VCC, rename it as VCC, connected ground. Okay. Then I want to connect that relay. So for that, selecting a resistor of 10K, place it here, connecting, and then we need an isolation, so that I am using an optocoupler. I am selecting PC817. Yeah, place it here. So I want to say that here the space is very less. If the circuit is very much higher, we can place that components, or we can place the circuit somewhere else where the place is sufficient. So I am removing this connection and placing it somewhere else where the space is sufficient. I am placing somewhere else. Yeah. Okay. Then how to connect the pin 14 to here? So there is another terminal known as default. Go to terminal mode, default. I have to rotate that. Yes. Place it here. The same default is given here. Okay. Then how do the system identifies the pin 14, the pin number 14 is connected to here. So we have to rename this default, double click here and give the name, that is a relay, and give it as a relay. Click on OK. So from here also you have to name it as a relay. Double click here. Then here you can type it is an relay, you can type. Otherwise you can click on this drop down arrow, click here, you can select it here. I always advise to click on this drop down arrow and select the relay. So when you give it as first time, you type it as a relay here, and if that same pin is used somewhere else, you just give the name by clicking the drop down arrow, because sometimes in the first time we are using the full capital letters. If you are giving the small letters here, the system will not identify that the 14th pin is connected here. So system will not identify. So you have to give the capital letters. So it is better to click on this drop down arrow, then select the relay and then give it. Okay, so there is a less chance of mistake. Then give the connecting the ground here. Then I have to connect a resistor. Connect VCC. And here I want to connect a transistor. And the subcategory selecting bipolar n-pin transistor. Connecting a ground. Next I want to connect a relay. Selecting the first one. Now VCC. Need to connect a freewheeling diode 1N4007. High to rotate. To connect that relay outside the PCB, we need terminal connectors. Click on P, terminal block. I am selecting a 3 terminal block. So this is a schematic diagram for interfacing a relay. Save it, and now we can save it as a PDF also. Click on File, Export Graphics, go to Export Adobe PDF. Click on OK. The PDF will be generated. Go to that Proteus folder. This is the PDF file. Yeah, this is the schematic we have drawn. Now we can design the PCB. Go to the PCB layout tab, click on the component mode, where all the components that we used in the schematic is listed, all the components. First selecting the Atmega, so it is selected, the mouse is moved to that space, click on here, it is selected, it will be on the mouse pointer, click on here to place that. Okay. Then I am selecting C1. So the green line shows the connections. We want to rotate that, rotate it. C1, then C2, okay, then R1, between that C3, you have to rotate that, place it here, then RL1, then J1, I want to rotate that, okay. Place a crystal here, R3, U2, Q1, finally R2. Okay. So just place that component, and if you rearrange that, you can reduce the size of the PCB. Now we have to create a board edge. Click here, the box mode, 2D graphics box mode. Then click here to select the board edge, and place the mouse. Click here, then drag and place it here. So this is the board edge. Okay, and you can name the PCB. Go to this text mode and select the top silk and click the mouse here. Here you can name the PCB. Okay. Now go to the routing. So there are some design rule manager. Click on here and click on net classes. So we have powers and signals. In case of power, we are giving the track width is somewhat higher. So selecting the power and giving 40, the width is more, and for signal I am selecting 30, T30, track width is 30. Click on OK. Then go to auto router, click here and click on begin routing. So it will be automatically routed, wait for some time. Yeah, it is automatically routed. and in the underground there is a showing that it is one missing. So this is that missing. Yeah, I am connecting, and if we rearrange, we can this is a small circuit. If we rearrange the components, we can reduce the size of the PCB, and also we can reduce that connections. I mean, that is the missings, eliminate the missings. So I am not going to that, and I will show you how to give the components or how to route manually. So just I am deleting this track, and it is shows the two missings, and this is one of the missing, and how I will show you how to route it manually. Then go to this track mode, click here, and it is selected as 30, that is the size of the track. Click it here, then mouse, release the mouse, then it will be automatically drawn. So click this 0.1, click here, so it is routed, and there is that two missing is reduced to one missing. So this is the way we can route it manually. And here we can give a jumper. I will show you how to give that jumper. Once again, I want to say that if we rearrange the components, we can reduce the size of the PCB and also reduce the missings also. Okay, how to draw the jumper or how to provide the jumper. So click on this track mode, click it here, then place it. Come here, double click so that there will be a hole, and then place it here. Again double click, then place it here. So this is a way of providing jumper. So this is the PCB. Now we can see the 3D visualization of this PCB. On the top, click here the 3D visualizer. So this is the 3D. Visualization. Okay. Now there is a hole, there is a two holes, and this indicates a jumper. We provided a jumper in the PCB, and it is shown here. This is a single layer, so the track is on one side, another side we place the components, and we can save this as a PDF too. Go to File, go to Output, Export Graphics, Adobe PDF. Here selecting the bottom copper, then give to OK. Yeah, this is the bottom copper part. Rename. Now output, export graphics. We can check the top silk. Yeah, here we place the components, that is the diagram. This is the way we design PCB using Proteus. Thank you.